It's a little bit after 9 o'clock in the evening on Wednesday the 31st of August. We were just watching Get Smart, and this would be the last day it's available on Netflix, so I had to spend a little bit of time interspersing multi-star alignments with watching. Missed it by that much. Of course, I'm missing the stars by about that much too in the alignment. I'm not having much luck with it. I am improving it. I'm actually paying attention now to the error values displayed on the handheld device associated with. Today I minimized the RA as much as I could, and I'll continue to work that issue because not being able to see Polaris makes getting the mechanical alignment on the azimuth and the declination very, very difficult. Right now I'm trying to orient the scope to Ras Al Gethi because this is my first flip to the west. Seems to be off by quite a bit, so I'm going to do a quick alignment here, and then I have to get on to Planetaries. Most of them are going to be pretty much culminating at this time because Vega, which you can't see, is almost on the zenith, slightly to the east. Well, somewhere on the screen I'm about to show you, which is actually amplified pretty high, using the CCD image or magnification function, is NGC 688 a Planetary Nebula in Cygnus. Magnitude 14.3, and I haven't had much luck with 13.1s, and I certainly haven't had much luck with 3x3 arc-second size planetary nebulas. But apparently the central star is magnitude 15. This one's incredibly distant, 17,400 light years away. It's in good sky position near the zenith. I don't have much confidence in this, but let's have a look. Dark band, just above the dark band, gives you the best view of the screen. I'm running at 64 flood, 36 auto gain. I'm using a setting of 100 on the e-zoom function, which basically should be about 150 to 200x. Lots of loaded stars. I did center on Alberio before coming here. Looking at the screen, one thing I've learned is that planetaries take a while longer to assemble on the screen after any motion. So what I'm going to do is make a slight shift in the position, and maybe that will give it away. Okay, the one thing that was right near the middle of the screen disappeared completely with the shift. Let's see if it reassembles itself. Now, if I remember right which direction I went. Yep, there's that little faint guy. It's taken a while to regenerate. That is likely to be our Planetary Nebula. It also has a slightly different color. Tiny 3x3 arc seconds. Wow. Pretty good confidence. That's our little sweetie. So very distant. So tiny. Interesting field of stars around it. Gives you a real sense of depth. Well, that's it for 6881. And once again, at 256 flood, 36 gain. NGC 6894, Planetary Nebula in Cygnus. Magnitude 14.4, 44 by 39 arc seconds, 5,400 light years distant, with a central star of 18.3. This is going to be on the limit, but I do think I am seeing on the screen, and so can you. That is amazing. That's a 14th and a half magnitude Planetary Nebula. Almost overhead in the clearest part of the sky on a very decent night of seeing. Now we have a notion of 14.5 planetaries, very large. I am most impressed by this, but boy, it's taking every bit of exposure time to see it. 16 seconds of exposure, 6 iterations of some 3 seconds each. At high magnification, 150x, and there's our planetary. I am, well, like the planetary, blown away. Despite the fact that NGC 7008 is magnitude 12, I love the size, 86 by 69 arc seconds, with a 13.9 magnitude central star and only 2,800 light years distant. Its declination of 54 degrees north is just too much. We're blocking it with the roof section of the observatory. It has yet to culminate, so I'll check it when the scope can point straight up, but I don't have a lot of confidence in this. I would assume anything above 54 degrees north declination is outside our reach. So we'll move on. Hey, looks like there could be some joy in NGC 7026, Planetary Nebula Cygnus. Magnitude 12, 25 by 9 arc seconds. Should be rather elliptical with a central star of magnitude 14, located at a distance of 7,700 light years. Its declination is 47, almost 48 degrees, but I am seeing stars form on the screen. That doesn't mean we're using full aperture. So here's the question. Watch as it forms. 16 seconds, and I'll try to be still. It's a smallish planetary. There's lots of blobbish stars up there. And they all are a little bit bent due to weight shifts. It's fairly bright. Could ever get to the point. Now remember, it's kind of elliptical in shape. Let's give this baby a chance to stabilize. Remember, I'm at 256 flood. And despite the fact I've got image stabilization on, it doesn't guarantee anything. Even the tiniest weight shift on my part seems to cause issues. And I'm in a very awkward position. Given the magnitude of this cluster, or planetary, I may want to drop down to 128 flood and eliminate. Oop, I think I see it. One thing I've noticed about planetaries is their color is different. In addition to the fact that they tend not to regenerate themselves as quickly as stars. But if I had to guess where the planetary is, I would say right about there where I'm pointing. So watch as I I can't really disturb the image very well, not at 256 flood, but I'm going to drop it down to 128 and we'll have a look at it again. Okay, I've dropped the sensitivity of the flood rating exposure time to 128 from 256 to try to eliminate all the distortion in comet tails on stars, etc. We're still at NGC 7026, that planetary nebula in Cygnus. Very bright, fairly large but highly elliptical, 25 by 9 arc seconds, with a central magnitude 14 star, 7,700 light years distant, and it is culminating at this point. I expect that we should be able to find this on the screen, except we may not be able to recognize it. But once again, I'll point out, wow, there's so many weird-looking elliptical-shaped things on the screen. Although those are double stars, apparently. This may very well be. And I'll do a little disturbance of position on the screen so that we can see how quickly the images regenerate. Here we go. Again, I'm going to say that's my candidate right there, but I can't be sure. It's only probabilistic, like most things in life. Just shifted the weight, of course, and you saw how much of a disturbance that was. I'm going to wait for the scene to prettify itself before I bail on it. There we go. NGC 7048, Planetary Nebula in Cygnus, magnitude 11, excuse me, 60 by 50 arc seconds with the 18th magnitude central star located 5,300 light years from our own system. And again, just skirting the roof tries of the observatory. Here's our view. Remember, it's supposed to be about 1 arc minute in size. Fairly bright. Should be obvious, really. Flood is I'm causing some disturbance of the scope. Given it's bright, oh, it's forming. I can see it right in the middle of the screen. Took it a while. Large? Is that the central star I'm seeing? There you go. Boy, that perfectly lined up, didn't it? Right where it should be. Very center of the screen. Okay, here's another. Be patient. Try not to disturb the floor of the observatory, the telescope itself. Use high, especially for these large planetaries. Use long exposure times. I've also got the color setting, and I'm probably doubling the magnification at minimum. So we're down to fairly small screen area sizes now, maybe 10 by 15 arc minutes. And here we have a 1 arc minute size planetary nebula right in the middle of the screen. Okay, moving on from Cygnus, we're now in Sagittarius. Ic-4997 is a planetary nebula. It also has a designation of PK58-10.1, at least that's my speculation. Central star is of magnitude 14.6. We should easily pick that out. The nebula itself is magnitude 10.5, and it's 22 arcseconds, I believe, in size. It's closer to, Sagittarius is closer to the celestial equator, so the scope is tilted out a little bit. And here's what we're seeing on the screen. 22 arcseconds. This one was missed by Dreyer. Not that you can expect anybody to find everything. Frankly, I'm seeing a little bit of nebulosity around this star right here. For 22 arcseconds, I don't know. And the center, it's supposed to be much brighter overall than the central star. So there's no way to be sure about this IC planetary. I can disturb the image a little bit, which is what I've done in the past. And we'll see what generates, what falls out. I couldn't tell you. Let's go back the other way. Got the camera, handheld camera in my eye. Gonna have to inspect this baby later. Well, it may be an IC, but I can't be sure that I have. Our next aging star is NGC 6886 in Sagittarius. Bright, 12.5, but unfortunately very small. 4 arcseconds with a 16.5 magnitude. Central star. This is a distant one at 14,200 light years. It's also in good sky position. Let's see what the screen presents us with. I'm going to sweep because I'm not getting a very good view here. Remember, this baby's tiny. Like, probably smaller than that insect that's climbing on the screen right now. I do not have a good view of the screen. The handheld is also over-illuminated for my eye. I will disturb the image and we'll see if anything comes out of it. For anything that takes a while to regenerate itself. Back in the other direction, I hope. Aha. Yep. This is the most suspicious of dots on a screen. It's got the color to it. It's tiny. It's fairly bright. Let's see if I can get a good view with the handheld. Alright, that's my candidate. Our next planetary is in Delphis, NGC 6891. Bright, 10.5, but small, 16 by 7 arcseconds. This one is very distant, 11,800 light years. Now keep in mind, something like the Ring Nebula, which I hope to be able to image again tonight, is like 2,000. So I've got a bright central star of magnitude 12.3. It's going to be kind of hard to distinguish the nebulosity. The central star is about a little less than 2 magnitudes fainter than the rest of the planetary. Sweeping the screen. It's pretty clear to me. This is our baby right here. The star, even though it's fainter, is overwhelming because it got more condensed light. It's overwhelming the sensor. So the nebulosity is just that little bit of an ear towards that bright star, neighboring bright star, which itself seems to have but itself potential nebulosity. Oh, looks like a number of these stars have that same basic feature. Very peculiar, which reduces my confidence that that's actually the planetary. This one should be fairly bright, folks, and I am having trouble. Wow, they all seem to have a little bit of a trailing nebulosity with them. Once again, I'll disturb them. We'll see what shakes out. Here we go. Oh, that bright star now pretty clearly doesn't have a nebulosity. It has 2 faint stars near it. One almost in the center of the screen. It's pretty clear though. It looks like all the stars are... I must be sitting very still. One little sweep, and with any luck I'll pick something out on the morrow during my day job. NGC 6905 in Delphinus, magnitude 12, love it. 44 by 38 arc seconds, that's great too. Central star at magnitude 14, very nice. 5,700 light years distant and well above the celestial equator. We should get a good view of this baby. And so it is. Central star and everything. Look at that color. Very nice. Wow. Nice setting. Beautiful. There's a brightening, there's actually texture inside this lovely planetary nebula. This is one every amateur should look for with their scope. Even with the 6-inch, you should be able to track this one down without imaging overdrive to be able to reveal it. I like this baby. I can see it on the screen. It's awkward to get at with the camera, but the view is fabulous. I think I'll take a still shot of this one as well rather than the screen cap. Hope you've enjoyed it. Well, here's a obscure little planetary nebula designated M57. It's in Lyra, magnitude 9.4. Fairly large, larger than most of the ones we've already imaged, 56 by 62 arc seconds, a mere 2,300 light years distant. And right now it is pretty much just past culmination, so it should give a fairly good view. Hopefully I won't have to play around with things in order to see something as bright as this. Ha ha. Here we have the Ring Nebula. It's central star, 14.5 magnitude at all. This deserves some exploration in terms of magnitude. I'm sorry, in terms of magnification. Plenty of texture, even some color. Blues in the interior, whitish leading to reds at the extremes in the 2 and 7 o'clock position. Maybe overwhelming this camera a little bit. I'll move in on it and we'll see if it causes any issues. I think I'm going to run the magnification up so we'll have a chance to explore this one a little bit. Because it's got plenty of light. Well, with magnification it should dim it out. But this is 128 flood at about 150 to 200x. Let's push it. Well, I can only imagine that this is like the 500x view. It's filling up the whole screen. In fact, you can see any weight shifts are really causing it to jump around. But look at that greenish color in the core. I'm at 240. I completely lost the ring as I boosted it to 250. I had to use the pan and tilt functions in order to bring the Ring Nebula back into the screen. We've lost the central star. The light is probably too diffuse. So the surface brightness of the ring itself is much greater than the star. Now what we want to do is, let's bring it back up to magnification and start dropping it down and see what happens with it. Where it's optimal. And we're starting to get something that looks like its usual shape now. I imagine if we get it down to a magnification where we can see the central star again. There's that bright 13th magnitude star that's just outside the ring's perimeter, just appearing now. Something I look through at the eyepiece. I believe it's this one here that I'm talking about, not the brighter one at the top. We're still running the magnification down. Image still doesn't have enough definition to it. I think the tilt and things is kind of messing it up. So I'm not really sure what that did for me other than bring the image back into the screen when I ran the magnification too high. Just keep on. Now maybe that's the 13th magnitude star way over to the right. And there's a fainter one right next to the ring. I'll know better when we get it down to a nominal size. I like the color, greenish color. What we're going to try to do is arrive at something that looks aesthetically pleasing. That looks best when I put the color bar, and I put that dark bar on it. Let's go back to, we're heading now towards 100, which was the original zoom magnification. I don't think I want to push anything beyond 100. I'll run it down to 0, or I'll turn it off before I exit here. I'm going to leave it at 100. Now we can see it again, now the core. Sweeping it. Okay, there's our 100. I'm going to try positioning the camera, get the best view. Doesn't seem to be revealing what I'm seeing on the screen. Right about there is where we get the donut appearance. Alright, that's not bad. Here we have our view of the Ring Nebula with EMAG off. It's about a 75
X view. Certainly it was twice that size when I had the zoom on, which was about 150x. You can still see the color in the center. Bright star may or may not be apparent. I can't see it from where I'm sitting. We have one more study to look at before we carpe noctem out for the evening.
Like the Ring Nebula M57, the Dumbbell Nebula M27 needs no introduction to amateur astronomers who have spent at least about a year touring the night sky. This is a Planetary Nebula in Vulpecula, magnitude 7.3, some 8 by 5.6 arc minutes in size, a mere 1,300 light years distant, and well above the celestial equator. Ladies and gentlemen, I give you the Dumbbell Nebula in Vulpecula and in color. And it should be a really good view given the fact that it is culminating. Now, I'm seeing it better on the camera here, screen, than I am on the screen. What I look for is you look for some kind of nebulosity here and here extending outside the bounds, plus a very clear sense of frontier at the 1 and 7 o'clock positions. Seeing some beautiful greens. I see the central star. But I'm not seeing the extensions I normally see. I'm going to go ahead and boost this baby up to 256 flood to see if we can really flood our eyeballs with color and luminosity. May not be the finest night for this. Typically I can see an extension of the nebular front in the 10 o'clock and 4 o'clock positions. However, the color is really cutting through. We'll back off the camera a little bit, let's see, and maybe do a little bit of zoom. Still not seeing what I want to see, but the color is lovely. Keep in mind that the Dumbbell Nebula is closer than the Ring. It's also presenting at a different angle. The Ring, you're seeing the poles. What we're seeing here is the equatorial aspect going out to the 2 and the 5 o'clock, or I'm sorry, the 2 and the 7 o'clock positions from the camera. Magnificent. Look at the color. Wow. Stars look pretty good. I'm seeing a couple of doubles up there. No comet tails. We're at 256 flood. 36 gain. I could push the gain even further. Probably not a bad thing to do unless I run out of battery on the handheld. And then we'll call it a seize the night. Carpe noctem. Got all the exposure settings maxed out. However, I haven't pushed contrast and screen brightness. Contrast and screen brightness are available both on the monitor here and on the imager itself. I'm looking at those stars, they're looking pretty round, so this is a good stable position for me to be imaging the dumbbell from. Let's take a look. If we push the brightness, what happens with this baby? 90 or so? Oh yeah. Now I see those extensions. How about you? Yep, there's that bubble-like extension. So pushing the brightness up really did bring out the rest of the nebula. Let's talk about the sharpness. Wrong way. So now we're going to start pixelating the screen.
that to 90 as well. Or close, right? Okay, now we're pixelating the screen. The color is really beginning to pop. So is the definition of the edge. So we're losing on the aesthetic, but we're seeing more detail. I love the purples to the 2 o'clock and the 7 o'clock position. The green band, it looks like a Superman coming down through here. And the lighter aqua color, sky blue colors there. Wow. I can do the same thing with the actual imager itself, increase the contrast and the brightness. But you know, I think we've pushed this as far as we really want to. I'm going to take a snapshot, but before I do, carpe noctem.